Top. Début de la séquence finale lanceur. Le nouvel aérovisé est 20h0 sur secondes.
So we have now reset the clock for a new launch time of 8 o'clock Universal Time. That's 5 o'clock here in Korea. And 9 o'clock in some European countries. We're live at the Guyana Space Center. We're launching 2 satellites, SICRAL2 and Thor7. They're up there inside the fairing. That is the nose of the launch vehicle for anybody who is not familiar with the launch. They're inside there. The team is here at the Mission Control Center, about 18 kilometers from the pad. We had a short stop in the countdown there, but the clock has turned green again and the countdown will restart. The status bars that we saw are representing all the different systems across the base, and they all need to be working properly for us to launch. And the clock ticks permanently as long as no hold sign is given, but if one turns red, it means we have to stop and think, and that's what happened there. We had a launch base red, and the red is a routine way to flag a warning. It tells the other systems to wait and hold their operations, and it allows the system involved in the red to understand and fix the glitch. There's our launcher, Ariane 5 on the pad. It's the 222nd launch from the Guyana Space Center for an Ariane launch vehicle. Run in its entirety in order for the vehicle to launch. It cannot be interrupted. That's why once we get to -7, we have to stop the clock if there is a glitch.
À tous de DDO, je confirme bien que la reprise du temps décompte reprendra à 19h53 TU. Pour un nouvel 0 à 20h TU.
Let's just confirm that we have a launch time of 8 o'clock. 8 o'clock UTC. UTC, of course, sometimes known as GMT, Greenwich Mean Time. Once we get to 7 minutes before 8 o'clock, the countdown will restart. As I was saying, the systems across the base send their information to the boards in mission control, and all of those have to be working correctly in order for the countdown to continue. And the synchronized sequence is the last 7 minutes of the countdown. That system has to run. Those last 7 minutes have to run in order. And if it's interrupted, the clock has to be reset. There's Ariane on the pad. We're looking good for the weather at the moment, it appears. Yes, cloudy skies, but we had the last few days here, we've had sun. We're of course on the edge of the Amazon rainforest. It's not called the rainforest for nothing. And you can see those big masts on the right-hand side are the lightning masts. There we go, the team's here in mission control. We have various different launch control centres and mission control centres here at the base. Mission control is the live centre, where the information comes here from across the range. And then each of the launch pads and launch zones have their own launch control centre. And these guys and girls are sitting behind what we call the fishbowl. Behind this glass, all the operational teams are focusing hard at this point as we come up to launch. Right-hand side, there's a range. There is the umbilical tower. connections. So if you look at the launch vehicle, you can see all those leads going from the launcher to the tower. And then if you follow your eye down, they travel down to...
Right at the bottom you can see what we call that launch table. And all these connections on the launch table, when the launcher is rolled out to the pad from the assembly building, it actually is rolled out on that huge launch table, so it arrives looking just like that. And you can see there the trees at the bottom there, the Amazonian trees and forestation. Because we are right on the edge of the water on the northeast coast of South America. Hot and humid. And the mosquitoes are just getting ready to come out around about this time. Not just yet, but soon.
Maybe that the folk in the viewing stations around the pad there might want to be getting their mosquito spray out.
Two passengers on board there, waiting patiently for the clock to restart. SICRAL2 and Thor7.
Thor7's at the top and SICRAL2 underneath.
Attention à la reprise du temps des comptes. Top. Début de la séquence finale lanceur.
And he's just announced the beginning again of the synchronized sequence where we have gone to the automated phase. The computers are performing a whole set of checks and controls now before launch, and they're managing a very impressive list of operations. And of course this is the final phase in a sequence of events bringing us to today.
Most of the elements that make up Ariane assembly of the launch vehicle not far from the launch pad in facilities dedicated to satellite operations. Preparation includes weighing and testing by special teams in clean rooms. All satellite systems are checked, everything from electric cables to solar panels. By the crews are quite heavy. They weigh 17 kilos. Meanwhile, Ariane Space and customer teams meet on a daily basis to review campaign activities. In all, the campaign took 6 weeks to ready both launcher and satellites. When filled, the satellites in their turn moved to the final assembly building.
Yesterday, news today, we are back in mission control, and as you read earlier, I mentioned that the base is a pretty
huge base that covers more than half the size of Rome, and there are so many different facilities here. There are launch fields, satellite facilities, and a whole range of other buildings. And we call it the range. That includes actually the downrange stations, or the ground stations, which are dotted along the flight path.
And they track the launch vehicle as it flies over. You can imagine the logistics involved in everybody communicating with each other, and that's why all the information is sent here to Mission Control, and everybody listens to the range operations manager.
So the other control room, which is important here, is the Launch Control Center. This is about 3 kilometers from the pad, and it's often known as the bunker. Various different teams working here. One's responsible for ground operations,
led by the launch site operations manager, and the quality team will make sure that all the regulations and rules are adhered to.
Another team refers to the flight readiness of the vehicle, led by the Ariane production manager, there he is, and they oversee the operations from the assembly of the launch vehicle to the moment of launch.
We also have a safeguarding team to make sure that all the operations are carried out according to very strict rules guaranteeing the utmost safety here
At the base. About a year ago, the computers on Launch Control sent the liftoff time to the computers on Ariane.
I'm talking earlier about the umbilical tower. You can see, you may not see them very well from this angle, but if you go up to the top of the vehicle, you can see two arms. We'll get another angle on this in just a second, and they are feeding cryogenic propellants into the upper stage
Of the launch vehicle. You can see them there, 3/4 the way up on the right-hand side. Two great big, what do you call them, the cryogenic arms, clamping
to the vehicle, and that's where they attach. The cryogenic fuel is actually incredibly cold, minus 253
degrees for the hydrogen and minus 150 for the oxygen. We have to keep them that cold in order to maintain them as liquids. And they do tend to evaporate, so we keep those arms there right until 7 seconds before launch, or
just before launch. You'll see them dropping away. The folk here going outside now to view the launch from the viewing station.
We'll see a 7-second delay between the initial ignition and liftoff. That's because we'll be checking the volcanism before we
À tous de DDO, attention pour moins 1 minute. Top à 0 moins 1 minute.
1 minute to launch, and we are live at the Guyana Space Center. We are orbiting Thor7 for Telenor and built by Space Systems Royal, and SICRAL2 for Telespazio, and French and Italian Ministries of Defense built by Thor7 Space. Our very best wishes to everybody involved
in today's launch. There she goes.
He says the propulsion is normal. We broke.
She flies over. I can feel the ground shaking. Blazing a trail across the sky here at the Guyana Space
Tous les
Center.
paramètres à bord sont nominaux.
After the initial 13-second vertical climb, we rotated to the west and over the Atlantic Ocean, but the boosters, those two big boosters, are doing all the work right now. They're providing 90% of our thrust. And if we get lucky, we might even see them falling away with the naked eye.
The boosters are burning at 3,000 degrees Celsius. The main stage that we're attached to is at virtually absolute zero, so you can imagine the incredible complexities of the temperatures there, the feat of human engineering.
And those boosters...
Séparation des étages d'accélération à poudre.
And those boosters are falling away. We've had
Confirmation there. We can see them, the two dots, just through the clouds, falling back to Earth. They burnt their propellant. We don't need them anymore.
just about 3/4 of our mass in just over 2 minutes. So now we're building the main stage. You can see it there, the grey structure, the big
La
tank.
trajectoire est nominale.
A huge tank of cryogenic propellant. It's going to burn for about 9 minutes. And you can see at the front there the fairing on the right-hand side. You can see the image there. The fairing is the nose of the vehicle, protecting the
Sont nominaux.
from the rigours of the launch from the side. The acoustic waves at launch, it's obviously very, very loud.
Largage de la coiffe.
And of course friction. If you look at the bottom left-hand side of the screen, you can see we're 114 kilometers above the Earth.
That means we're on the outer edge of the atmosphere. There's no friction in the air on the edge of space, and we don't need the fairing. So it falls back down to Earth, and we can see Thor7, our first satellite there. Everything's going according to plan. We can see Thor7 at the front
For the very first time, and the two grey rectangles are the solar panels. Behind it, we can't see it now because it's hidden under the cylinder, is SICRAL2.
Powering across the Atlantic using the Vulcan engine. It's very powerful.
It burns 320 kilograms of propellant-to-second. That's about 500 times more than a jet engine. The computer-generated images that we're looking at are showing us what the experts have planned and calculated is happening to the launcher.
Tous les paramètres à bord sont normaux.
He says, tous les paramètres à bord sont normaux, all the parameters on board are normal. Then we're seeing there the tracking station at Gaia. That's the tracking station at the Guyana Space Center. And the computer-generated images are
what's actually happening in space. Basically, the teams plan a very precise schedule of events based on extremely accurate predictions. And they put all of that information into the computer, and these images are a simulation of those predictions.
We took off 5 minutes and 23 seconds ago.
As I was mentioning, these computer-generated images are really showing us pretty well what's happening, exactly what we're expecting to be happening.
La propulsion est nominale.
And we'll do another replay there of a superb launch. The folk in mission control. If you look at the bottom of the screen, you can see our altitude there on the left-hand side. We are 163 kilometers above the In the middle you can see the distance. That's the distance from the pad if you were to draw a line across the ground. And on the bottom right-hand side is our speed at the moment we are travelling. 4.2 kilometers per second, ladies and gentlemen. Let me, boys and girls, let me remind you that's per second, not per hour. So we are travelling at fairly speeds. And we're heading out across the Atlantic.
Il reste 2 minutes de propulsion EPC.
Now it says we've got 2 minutes left of propulsion in the main stage. Our flight path takes us along the equator towards Africa. And we'll start separating the satellites just over the east coast of Africa. Picking up speed all the time now, you can see the trajectory on the top right
Est nominal.
side of the screen. The curve is the predicted trajectory of the vehicle, and the dot is the actual position of the launcher.
Tous les paramètres à bord sont normaux.
And we're tracking our launcher using ground stations as she flies over. It's called telemetry. They've got great big dishes, a bit like ears. They're listening out for the launcher. And sends data to those ground stations, which tells us how the flight is progressing in real time. And later we can see how the vehicle performed in a process which is called the Level 0 flight evaluation. And you can see there we're picking up the signal there at the next tracking station in a tower on the northeastern coast in Brazil. He's just given us the confirmation now that we've picked up the signal, so we've travelled from Brazil. You can see the tracking station on the left and the west in the Ariane Space Centre, and the tower in the northeastern coast of Brazil. Talking about advantages for launching from the equator, it's the fastest route to geostationary orbit, and also the natural rotation of the Earth gives us additional speed on the equator. So if you think about it, the launcher is actually already moving in the right direction, even though it's on the pad. Obviously that's when we're launching to the east, of course.
Fin de propulsion de l'étage principal cryotechnique.
Main stage has cut off its engine, it's burnt all its propellant,
Séparation EPC.
and it's falling back down. There are images from a previous launch. We had cameras on board a previous launch. Look at that, superb. And you can see the curvature of the Earth. And the main stage as it falls back down. So we are now entering the next phase of the flight. The upper stage has taken the wheel, and its job is to deliver our satellites to their orbit. We're shedding weight, of course. We started with 774 tons, and we've got about 3% of that left. The lighter we are, the faster we go. It might seem obvious to us now, but it wasn't always actually. It was, of course, Sir Isaac Newton who identified that back in the 1680s. That's when he presented his 3 laws of motion. And then about 20 years earlier, he'd developed his theories about gravity, and of course that was all an apple fell on his head, and he was only 23 years old at the time, so it's quite remarkable. Of course, most of the laws at the heart of that are also at the heart of rocket science. Our first satellite to be separated by VA-222, the Tesla flight.
Est nominal.
Our France Space Systems manufactured it for Telenor using their LS-1300 platform. This is the 47th satellite built by L'Oréal that Ariane Space has launched, and there are 15 more in the order book.
leading provider of commercial satellites, with a broad range of capabilities to support satellite
operators and innovative space-related missions. Telenor's Satellite Broadcasting, a major provider of broadcast and data communication services, owns and operates the Thor satellite fleet, positioned at vertical west, which provides high-powered and high-quality satellite capacity throughout North,
the Middle East, and Africa. Together, SSL and Telenor have partnered to expand the benefits of
the digital world with the multi-gigabit, high-throughput Thor7 satellite. The spacecraft is a multi-mission satellite.
Features Telenor's first high-performance Ka-band payload for the maritime market. It is the highest performing satellite payload designed specifically for service to ships at sea. The satellite also includes a Ku-band payload, which will provide growth capacity for TV broadcast services.
Thor7 is actually a very important satellite for our company. Unlike our previous satellites, Thor5 and Thor6, that were replacement, in orbit for older satellites, this is really a brand new satellite for expansion. So in other words, it's going to give us opportunities to grow our business both in the broadcasting area as well as in the data communication area.
The satellite's Ka-band payload has up to
25 simultaneously active spot beams, offering up to 9 gigabits per second throughput for cost-effective solutions and high-power coverage over the North Sea, the Norwegian Sea, the Red Sea, the Baltic Sea, and the Mediterranean. This translates to reliable download speeds at
tens of megabits per second, even to small antennas, and uplink speeds up to 6 megabits per second. The satellite's Ku-band payload
has 11 transponders and provides expanded broadcast service to meet the demand for high-definition television in Central and Eastern Europe.
At SSL, in Palo Alto, California, a very skilled and experienced team of engineers and technicians work diligently to make Thor7 an exceptional satellite. This spacecraft is based on the highly reliable SSL 1300 platform and implements innovative and sophisticated technologies to complement Telenor's full fleet of satellites.
SSL and Telenor share a tremendous focus for quality and reliability, and certainly, as we have proven, integrity in our business relationship.
SSL would like to thank its customer Telenor for putting its confidence in SSL's technology and leadership in designing and building commercial satellites. For SSL, it was a privilege to furnish
Thor7 to Telenor, a company that prides itself on providing the power of digital communications to improve lives and secure a better future for all. Thor picked up the signal at
the tracking station in a little tiny island in the middle of the Atlantic called Ascension Island. It's volcanic. It's about 88 kilometers
square, and around the world, I think it's got roughly about 1,000 people around. According to Wikipedia, the territory includes the largest populated archipelago on Earth, the Tristan da Cunha archipelago. And Ascension Island played a very important role
during the Apollo era, and right now the teams are picking up the data from Ariane and sending it to the telemetry team here at the Guillaume Space Center. 144 kilometers above the Earth, we are coming up to 4,500 kilometers from the pad along the ground. And look at that speed. We're really, really starting to pick up speed now, whereas all our power before was getting us away from the Earth. We're just starting to climb in altitude. We need to pick up speed to do that.
So you can see there the trajectory on the right-hand side. You can see that the initial ascent was very steep and I plateaued out a bit, and that was so that we could pick up speed, so that now at this point in our flight we can really start to climb.
You can see If you look at the right-hand side, you can see the flame of the engine of the upper stage. The sort of grey and white disc is the upper stage of the vehicle. Now, if you travel around to the left, you can see a black structure. That's what we call the cylinder. It's protecting the SICRAL2 satellite, which is underneath it, and at the front you can see, or you could see there, Thor7. This is the second time that we've launched for the Norwegian operator, Ariane. And here the SICRAL teams. SICRAL is a wholly European project. It's a European military satellite built and operated by European industry, delivered to space by Europe's launch service provider, Ariane Space, of course. And Thales Alenia Space built it at their satellite facilities in Rome. Ariane tested it in Canada. It's actually the 41st time that Ariane Space has launched one of their satellites, so they've got 10 years book. And the people in charge of the ground segment are Telespazio. SICRAL2 is for the Italian Ministry of Defense and the French Military Procurement Agency, and this is the 30th satellite that Ariane Space has launched for them. And I think it's very fair to say that space is becoming increasingly important for supporting military activities. Until a few years ago, space was limited to strategic intelligence. Now it plays a hugely important role in ground operations.
Il progetto del SICRAL2, il progetto di questo satellite, è stato voluto dal Ministero della Difesa italiano e dal Ministero della Difesa francese già nel 2007. È un progetto molto importante, un satellite di grandissima flessibilità, pensato, progettato in Italia e frutto della collaborazione fra i nostri due paesi. Ma forse lo spazio è fondamentale per le forze armate e non solo. E aver prodotto un satellite di questa qualità e con queste caratteristiche va sicuramente ad onore sia dell'Italia che della Francia. In questo modo noi costruiamo anche un pezzo della difesa europea. L'Italia e la Francia sono gli elementi che sono riusciti a finanziare un progetto così importante nel campo che si focalizza nel futuro per lo spazio. Possa aprirsi ad altri paesi europei, perché sappiamo che la vera costruzione della difesa europea si costruisce attraverso la capacità di portare avanti progetti comuni come questo. Quindi i migliori auguri a SICRAL2.
Buonasera. SICRAL è una storia di successo. Un successo che ha consentito al Ministero della Difesa italiano di acquisire una capacità operativa primaria del mondo. È un successo della nostra nazionale che ha consentito di sviluppare tecnologie, prodotti, soluzioni e competenze a disposizione di questo piano. Siamo particolarmente orgogliosi di aver contribuito sin dalle origini e oggi da contribuire nella messa in orbita del satellite, nell'inserimento nell'orbita finale, nei test che saranno fatti per validare il funzionamento in orbita e infine potremo andare in condizioni preparate da noi sviluppato grazie anche attraverso il nostro centro del Fucino. Ringraziamo tutti, ringraziamo il Ministero della Difesa italiano e francese e ringraziamo tutti i nostri partner e colleghi dell'industria perché è stato uno sforzo grande e che ha portato sicuramente a dei risultati misurabili. Ora dobbiamo guardare avanti. Dopo il pathos di questa sera dobbiamo pensare al successo futuro della famiglia SICRAL. Spazio è responsabile dello sviluppo, realizzazione, integrazione e verifica del satellite controllante planetario
e secondario presso la sede del Fucino. Inoltre è anche responsabile della realizzazione del sistema di interconnessione tra i centri di controllo missione italiani e francesi. In aggiunta a ciò, Telespazio gestisce il servizio di lancio, le fasi di LEOP e di IoT, le prime fasi di acquisizione del satellite in volo. Come già fatto per
la missione SICRAL2, Telespazio ha cofinanziato la missione SICRAL2 e pertanto a zero di servizi telecomunicazioni per le forze armate
alleate.
SICRAL2 is an end-to-end system composed by the space segment, that is the satellite, and the ground segment, which is devoted to the control of the satellite and the management of the communication. In this context, Thor7 Space has been responsible for the overall architecture of the development of the satellite, communication control.
To share with you this unique moment in the life of the SICRAL2 program. SICRAL2, as well as Athena Fidus, launched in February 2014, are symbols. They are concrete examples of cooperation in the field of governmental space telecommunications, called for by the European Council in December 2013. Military space telecommunications is unrivaled. This expertise has been built over the last 30 years in Italy and France with the SICRAL and SICRAL2 programs. These investments have led to the development of know-how and resources which are essential for the
l'industrie française de la recherche internationale. Ces SICRAL2.
And unbelievably, we crossed Africa during that film. The tracking station in Libreville picked up the signal about 5 minutes ago.
SICRAL program director, and that's on the west coast of Africa in Gabon, and Malindi in Kenya has just picked up the signal, and which means we're now over the east coast of Africa, and Malindi will be tracking us from now on.
We're really climbing into space. You can see there on the right-hand side the trajectory and our altitude there, 500 and coming up to 532 kilometers above the Earth. We're traveling at a speed of 9.23 kilometers per second. We're getting close now to the point where we'll be switching off our engine. And to do that, we need to get to 635 kilometers above the Earth. That's another 100 kilometers to go, and we'll see that we're going to do that very quickly. To send the cut-off command? Well, it's very clever. It has its inertial guidance system which senses the orientation of the launcher. You can see there. Our scheduled cut-off time? We've switched off our engine and we're entering what we now call the ballistic phase.
Extinction de l'étage supérieur cryotechnique.
We have confirmation there from the range operations manager that we've switched off the engine. The upper stage is now entering the ballistic phase. Ballistic actually means without propulsion. We're travelling high enough and fast enough to cruise without the engine, and this actually means that we are now on our orbit. We have to climb a little bit higher before we can start separating Thor7. Our separation orbit is actually 1,126 kilometers altitude. It's going to take us another 3 minutes or so to get there. Just to the SICRAL2 trajectory orbit will be 2,427 kilometers above the Earth. That's about 1,300
kilometers higher than Thor7. So we're going through a
very carefully planned set of manoeuvres, and we call this the Space Ballet because it's a bit of a dance in its own right.
just orientating the satellites. Once we release them, they continue getting on their own. They'll have to travel for about 5 days to get to their final orbits. They'll have to climb up to 36,000 kilometers above our planet. And in order for them to do that, we have to put them in a very precise position, a very precise attitude. And in order to do this, the upper stage has a brain. It's controlling all of these maneuvers, and it's in what we call the vehicle equipment bay. It's very smart. It's made of 2 computers, and it can even take its own decisions. It takes into account information from the tank, from the engines, etc. And then if there are different options, it always chooses the one which maximizes the success of the mission. Satellite has to be positioned into a different orbit, and the upper stage has to twist in any direction that we want in order to be able to do that. And it has 6 thrusters, which give tiny little bursts of gas. And those thrusters can move it in any direction we need it to go. Don't need much power to do that. So we're getting close now to what we call the injection point. That's where we will separate the first satellite, Thor7. Remember the altitude was 1,126 kilometers. Getting close. Concentration levels very high at this point as we wait for separation. We have confirmation now that we have separated Thor7, our first satellite. Congratulations to Tony and Space Systems Loral and all the teams involved. There we can see it separating there. It's actually being pinned into space by a set of springs. A set of springs, a little bit like a jack-in-the-box. When we open the box it pops out, and that's exactly what happens. We can see Thor7 moving away there. It's all very carefully planned in order to avoid parts bumping into each other in space. It's called collision avoidance. So Thor7's now heading out on its own journey. It's got to get to its orbital slot, which is 0.8 degrees west. And it's got to climb to 36,000 kilometers above the Earth. It's going to take it 5 days to get there. Here again we see we have SICRAL2 attached. It's underneath that black structure, the cylinder. And so Ariane has more work to do. We need to climb to 2,400. And he's telling us that all the maneuvers are going nominally according to plan. It's going to take us another 4 minutes or so to get to our next separation orbit. We've got a few more maneuvers to perform before we can get there. Just to remind you, these computer-generated graphics are showing us all of those movements. We're watching exactly what's been planned. The experts have put the data into the computer and it generates these images. So this is effectively what's happening in space. Every time you see a twist or a turn or a flash of an engine, that's exactly what's been planned. So Thor7 deploys its solar arrays after separation. It's going to have to power up. When satellites deploy their solar arrays, it's a little bit like a butterfly coming out of its cocoon. The teams are taking it over now, and tomorrow it'll switch on its engine for the first of 4 burns. That's going to take it to its orbit. And in 8 days' time it'll deploy its reflectors, switch its payload on in 10 days, and in 12 days' time it'll start testing. Best of luck to our teams with the next phase of those operations. Right now, the teams here at the Guyana Space Center are receiving the telemetry. Here we can see them. It's called the CVA, Real-Time Visual Control. As I said earlier, Ariane sends information to the tracking stations as she flies over, and those tracking stations send the data here to the CVI. They receive more than 100 pieces of information at any one time. To make quick selections to check how the flight is progressing now in real time, and then later on they'll be analysing all that data just to see how the flight progressed and make any changes they might need to make for the next flight. Right now it's the teams in Malindi who are receiving the information and sending it to them, to the CVI. Important time for all teams tracking the vehicle, and everyone's poring over the data right now and concentrating hard. This is the third launch this year from the Guyana Space Center. We had 3 launches using 3 different vehicles for 3 different applications. The first launch was the baby of the family. That was back in February. Vega orbited a European Space Agency craft, and then we had in March Soyuz, the medium lifter.
Normal des manœuvres d'orientation.
And today, of course, Ariane 5, Daddy Bear, taking Thor7 and SICRAL2 into space. Ariane 5 is the only vehicle in the world that can hoist 2 45-ton satellites into space at the same time. That's the black structure moving away, the cylinder. Known in French as the Système de Lancement Double Ariane. The cylinder performs various functions. It's a little bit like a fairing. It protects the lower satellite, and it also provides the attachment system. And there we can see on the right-hand side SICRAL2 for the first time. And you can see its solar panels there.
Au profit de SICRAL2.
Is what makes those 2 launches possible in Ariane 5. And SICRAL2 is the 63rd military payload launched by Ariane Space. We're at 2,276 kilometers above the Earth, and you look at our speed, we've slowed down fractionally. That's because we've switched off our engine. We're travelling now at 8.13 kilometers per second. 12.5 kilometers, 1,000 kilometers from the pad if we were to do it anywhere across the ground. And we're coming up on separation now of our second satellite. The mood here, very focused. High levels of concentration. People have been working very hard on both of these projects. Some people are working over 3 years. And teams have been working very hard over the last few days.